Hello children, today in this lecture we will discuss chemical properties of amines, and the first reaction is reaction with alkyl halides. This reaction is also known as alkylation of amines. So in this reaction amines are reacted with alkyl halides, and hydrogen atoms which are present in amines with nitrogen are get displaced by alkyl group. Okay, so you can say that under alkylation reaction alkyl substituted amines are formed due to the displacement of hydrogen atoms. Okay students, so as you remember that this reaction we have already discussed in alkyl halide chapter and also in the preparation of amines. But again we are discussing same reaction here also. So as you all know that in the case of primary amines the functional group is NH2. So this functional group is having two hydrogen atoms. So these two will be displaced under alkylation reaction one by one. Okay, so you can say that primary amine will be converted in the form of tertiary amine finally. Okay, but secondary amine is having functional group as NH with one hydrogen atom only. So after alkylation this hydrogen will be displaced and secondary amine will be converted in the form of tertiary, and after that it again converted in the form of quaternary salt. Okay, primary can also be converted in the form of quaternary salt. So secondary will after first alkylation converted in the form of tertiary amine, and again further alkylation it will be converted in the form of quaternary salt. But in the case of tertiary amine only nitrogen atom is there in the functional group, no hydrogen atom. So this tertiary amine will be converted in the form of quaternary salt after alkylation. Okay, so all three types of amines are giving this alkylation reaction. Okay students, so in the case of quaternary salt the fourth alkyl group is attached with nitrogen atom through coordinate bond, which is formed due to the presence of lone pair electron with nitrogen atom. Okay students, so this reaction is known as alkylation. So as you can see from here, this is primary amine, and with alkyl halide first one hydrogen of the amine is displaced with this alkyl group. So here secondary amine is formed which is having one hydrogen here. Now on further alkylation with alkyl halide this hydrogen will be displaced, and then you will get tertiary amine which is having no hydrogen. But this tertiary amine on further alkylation with alkyl halide will converted in the form of quaternary salt. Okay students, then aromatic amines also undergo alkylation when treated with alkyl halides. For example, as you can see here in the case of aniline, on first reaction with methyl iodide and substituted methylamine is obtained, and again further methylation with the help of methyl iodide dimethyl substituted aniline is obtained, which is actually a tertiary amine, and under same condition at last quaternary salt is formed. Okay students, the next chemical reaction is reaction with acid chlorides and acid anhydride, and in this reaction hydrogen atom of amine is get displaced by acyl group. What is acyl group? the group COR. This group is known as acyl group. Okay, and that is why this reaction is known as acylation reaction. So in acylation reaction of amines, amines are reacted with acid chlorides or acid anhydrides, and we obtained acyl substituted amines. So in these reactions, for example, when amine is reacted with acid chloride, so in final state an alkyl alkanamide is obtained. So in this product, this amine and this part is present here. So you can see here that one hydrogen atom of the amine get displaced by acyl group. Okay students, get displaced by acyl group. So one hydrogen is get displaced by acyl group, and the formation of acyl substituted amines is taking place. In the case of acid anhydride, if you take an acid anhydride for the acylation, then you will get acyl derivative of amine plus alcohol plus acid, sorry, not alcohol, it's acid. So acyl derivative of amine plus acid. Okay, so as you can see from here, in this case we taken secondary amine here. So of this amine, this hydrogen is get displaced by acyl group. Okay, this hydrogen is get displaced by acyl group, and this hydrogen is joining to this oxygen atom. So you will get acid as byproduct, and main product will be acyl derivative of related secondary amine. So this is acyl group. Okay students, for example, when methylamine is reacted with ethanoyl chloride, so in ethanoyl chloride, this group is known as acetyl group. Acetyl group. So when this ethanoyl chloride is reacted with methenamine or methylamine, then you will get N-methyl ethanamide. Okay, so here you can see that this one hydrogen atom of methenamine is get displaced by this acetyl group. Okay, so introduction of acetyl group in amine is known as acetylation. Acetylation. So acetylation is a type of acylation. Okay students, acetylation is a type of acylation. Now in the case of aromatic amines, acylation in a similar way. However, in case of aromatic amines, the acylation reaction is usually carried out in the presence of a base, such as pyridine as catalyst. Okay students, so as you can see with the help of this example, when we are going to do the acylation of aniline, so we will use pyridine as catalyst, which is a base also due to the presence of lone pair electron with nitrogen atom. So one hydrogen atom of this NH2 group will be displaced by acyl group, this acyl group. Okay, so an phenyl ethanamide will form. Okay students, the next reaction is reaction with nitrous acid. So all the three types of amines are giving this reaction, that is primary, secondary and tertiary, and both aliphatic and aromatic. Okay, so these all amines are forming different product with nitrous acid. Okay, so their mode of reactions are different, and also the formation and the type of product are also different. Okay, so in the case of primary amines, the product which is formed is diazonium salt, and this diazonium salt, due to its unstable nature, it converted finally in the form of alcohol. Okay, and nitrogen is formed as a byproduct. Okay, students, so only the primary amine is forming nitrogen when reacted with nitrous acid under the condition of 273 to 278 Kelvin temperature. Okay, so the first diazonium salt is formed, which is unstable in nature, and that is why finally alcohol is formed. Okay, students, and as a byproduct, nitrogen is formed only in the case of primary amines. For example, ethanamine, when reacted with nitrous acid, so first diazonium salt is formed, and in the presence of moisture, this diazonium salt get converted in the form of corresponding alcohol, and nitrogen is formed as a byproduct with hydrogen chloride. Okay, students, so this reaction may be used as a test for primary amines, because no other type of amine evolves nitrogen when treated with nitrous acid. Okay, then aromatic primary amines are forming diazonium salt as a product. Okay, so when aromatic primary amines are converted in the form of diazonium salt when reacted with nitrous acid and HCl, then this particular reaction in which formation of diazonium salt is taking place under this temperature condition is known as diazotization reaction. Diazotization reaction. Okay, students, so because nitrous acid is an unstable acid, that is why this acid is prepared in C2. In C2, what is the meaning of C2? Means at the time of reaction with the help of sodium nitrite and HCl. So sodium nitrite and HCl at the time of reaction will prepare nitrous acid, and this nitrous acid will further react with amines and diazonium salt will form. So in this case, aniline is forming diazonium salt, and this formation reaction of diazonium salt is known as diazotization reaction. Okay, students, but if the temperature is above than 278 Kelvin, then the final product which is obtained here will be phenol. Okay, students, then in the case of secondary amines, both aliphatic and aromatic secondary amines, these reacts with nitrous acid to form N-nitrosamine. So with nitrous acid, aromatic and aliphatic secondary amines are forming nitrosamine. Okay, students, so this nitrosamine you can see here in this example that NN diethylamine with nitrous acid is forming N-nitroso-N-ethyl amine. Okay, N-nitroso-N-ethyl ethanamine. So this compound is yellow oily compound. Okay, so next, in the case of tertiary amines, aliphatic tertiary amines are react with nitrous acid to form soluble trialkyl ammonium nitrite salts, and these salts decompose on warming to give nitrosamine and alcohol. Okay, so as you can see here that in the case of primary amines, the final product is always alcohol, but in the case of secondary amine, final product is yellow oily substance and nitrosamine. Yellow oily substance and nitrosamine. Okay, but in the case of tertiary amines, soluble trialkyl ammonium nitrite salts are formed. Okay, which produce nitrosamine and alcohol after heating under decomposition reaction. Okay, students. Then especially when aromatic primary amines are reacting with nitrous acid under the condition of 273 to 278 Kelvin, stable diazonium salt is formed, and this diazonium salt is stable under these conditions, but at higher temperature this will be converted in the form of phenol. Okay, students. The next reaction is Carbel amine reaction. Carbel amine reaction, which is also known as Carbel amine test or isocyanate test. Okay, so this reaction is given by primary amines, which can be aliphatic or aromatic. So in this reaction, primary aromatic or aliphatic amines are forming an isocyanate compound. An isocyanate compound which is having offensive smell, and by the formation of this compound, isocyanate compound, we can prove that the given amine is a type of primary amine. It can be aromatic or aliphatic. Okay, students. So in Carbel amine test, we use chloroform and alcoholic potassium hydroxide. So when primary amine reacts with a chloroform and alcoholic potassium hydroxide heated, then we get alkyl isocyanate or phenyl isocyanate compound, which is having offensive smell or foul odored compound. Okay, so this compound is proving that the given compound is primary amine. This reaction is known as Carbel amine reaction or isocyanate reaction. Okay, students. So for example, you can see here that ethyl amine, when reacts with chloroform and potassium hydroxide alcoholic heated, then you will get ethyl carbel amine or ethyl isocyanate, which is a foul odored compound with byproduct potassium chloride and water. Okay, students. And same way, aromatic primary amine aniline will also form a related isocyanate. Okay, students. The next reaction is test for amines. Test for amines, and for the testing of amines, we generally use two types of reactions. Two reactions are there. First is Carbel amine test, which we have discussed right now, and second is Hinsberg's test. This test is also very important, Hinsberg's test. Okay, so for the Hinsberg's test, we use a special compound, benzene sulfonyl chloride. Benzene sulfonyl chloride, the formula of benzene sulfonyl chloride is C6H5SO2Cl, and this compound is also known as Hinsberg's reagent. So this compound is used for the test of primary, secondary and tertiary amines. Okay, so in this test, the unknown amine is shaken with benzene sulfonyl chloride, which is also known as Hinsberg reagent, in the presence of excess of aqueous KOH solution, and different types of amines respond differently. Okay, students, for example, a primary amine gives a clear solution which on acidification gives a precipitate due to the formation of an insoluble N-alkyl benzene sulfonamide. So as you can see here, that when primary amine is reacted with benzene sulfonyl chloride, so this primary amine is having two hydrogen atoms. So one hydrogen atom is displaced by this Cl, and we get an alkyl benzene sulfonamide. Now when this N-alkyl benzene sulfonamide is reacted with excess of KOH, then this hydrogen of the N-alkyl benzene sulfonamide is displaced by potassium ion. Okay, so we get potassium salt, which is soluble in KOH. Now this potassium salt, when reacted with HCl or acidified with HCl, it gives an insoluble substance, which is an alkyl benzene sulfonamide. Okay, an alkyl benzene sulfonamide. So this is the case of primary amines. But in the case of secondary amines, secondary amines are having just one hydrogen atom. So this hydrogen atom is get displaced by benzene sulfonyl chloride, Cl, and we get this N-dialkyl benzene sulfonamide. But further this nitrogen is not having any hydrogen here, so it is not going to react with HCl. So there will be no change here. Okay. In the case of tertiary amines, because tertiary amines are having not a single hydrogen here with nitrogen, so these are not going to react with benzene sulfonyl chloride. So in the first step itself, there will be no any reaction. Okay, students. So in this way, we can distinguish between primary, secondary and tertiary amines with the help of Hinsberg reagent. So in short, we can say that with the help of Carbel amine reaction, primary amines are giving Carbel amine reaction only. Secondary and tertiary are not giving. But Hinsberg test is given by, with the help of Hinsberg test, we can distinguish between all three types of amines. Okay, students. Thank you.